You might be thinking, how on earth does forensic science get to share a stage with behavioural change? I'm so excited. Forensic science is really identifying that we're facing a behavioural change complex conundrum. So I'm here this morning to share with you why that matters, why it's so important, and what we can do about it. So there are studies out there that would suggest that each of us loses between 50 and 100 hairs every single day. Some of us, obviously, more than others. But a pretty incredible figure is that each of us is losing between 30,000 and 40,000 skin cells every single hour. So it might not surprise you if I tell you that when you get up from your chair later this morning, that it's possible that you may well have left a hair, maybe a fibre from your jacket, even your DNA on that chair. And if somebody else sits on that seat, they could pick up that hair, that fibre, your DNA. Now, ordinarily, that's not a problem. But what if that person who's picked up that trace of you goes on to commit a crime, and they leave a trace of you at the crime scene, and you become the prime suspect? Not all of us are going to commit a crime, but every single one of us could be accused of one. And so imagine, just for a moment, you're standing there in the court and you've got the expert explaining to the judge how that hair, that fibre, how your DNA is cast iron proof of your guilt. But you're sitting there and you know you're innocent, but in that moment you've got that rather uneasy feeling that it's you versus science. There are people out there who don't have to imagine that happening because it's happened to them. But it is still happening. So you might be thinking at this point, well, that's exactly what forensic science is for, isn't it? Isn't that what we see on shows like CSI, Silent Witness? You've got the crack team of sharp scientists, they've all got the latest tech, they follow the evidence and they find the suspect and they close the case. What shows like that are brilliant at showing us is the amazing capabilities that technology can give us. What they're not so good at showing us is the biggest challenge that is facing forensic science. So how have we got here? Forensic science is without doubt a technological success story. We can now identify smaller and smaller amounts of trace material, we can do it more and more accurately, and we can do it quicker than ever before. You've only got to be in this room speaking for a minute, so that's most of us, and the technology can now pick up your DNA from either that table in front of you or somebody else's chair. But the problem that forensic science has got is a problem that's gone under the radar. It's a problem that's not grabbing headlines, and it's a problem that has the potential to impact the liberty of thousands of innocent people. We are expert at being able to identify what a trace is, what a material is, what it's made of. But forensic science is missing a critical piece of the puzzle. At the moment, we don't have the data that we need to always understand what that evidence means when we find it. And that is a big deal. But how big a deal? It's a tricky one to answer. It's a question that the research team that I lead at UCL has been looking into. And there are a couple of studies we can draw on. The first is one that we did that came out last year. And we looked at cases that had been heard at the Court of Appeal. So if you think about that, that's a very small proportion of all the cases that are heard across the UK. And we looked at cases between 2010 and 2016. And we identified nearly 1,000 cases where criminal evidence was critical to those cases. And what we found when we looked into those cases was that in 22% of them, the evidence had been misinterpreted. If we go across to the US, slightly broader, the FBI did a study in 2015, and they showed that they were interested in hair evidence, and they looked at 268 cases where hair evidence had been used to incriminate a suspect. And what they found in their study was that in 257 of those cases, the evidence had been exposed to erroneous statements. That is 96%. In 96% of those cases, the hair evidence was misinterpreted. Just to really underline that, 35 of those cases, the suspect received the death penalty. What that 96% is telling us is that we've got a problem that technological advances alone can't fix. What that 96% is telling us is we've got a problem that could affect me or it could affect you if we're caught in the wrong place at the wrong time. But more than that, what that 96% is telling us is that we've got a problem that could affect you if your DNA or your hair turns up in the wrong place at the wrong time. We are experts at detecting what a trace is, whether that's gunshot residue, DNA. But to address this problem of misinterpreted evidence, we need to know what the evidence means. So if we find gunshot residue on you or your DNA on a gun, it's not enough for us to know that it is gunshot residue or it is your DNA. We need to know, did you fire the gun? And did you fire it this morning, or did you fire it yesterday, or last week? This all came home for me quite a few years ago now. I was working through the case file of a particular case. It was a murder case. And in that case, there was some absolutely critical forensic evidence. There were these trace metallic particles that were on the victim and in the suspect's vehicle. And as I was going through that case, I had what I really can only describe to you. You know that feeling when it's like ice in the pit of your stomach? Because in that case, these critical particles, the whole case rested on them. There was an assumption made about them in terms of when and how they transferred onto the victim. That assumption was interpreted as a fact. It was presented as a fact to the jury. And that fact led directly to the conviction of 2 people for a crime that they didn't commit. Misinterpretation of forensic science evidence is the biggest challenge facing forensic science, and it's a behavioural change challenge. Shows like CSI are brilliant. I'm a big fan. But what's been really interesting is that they've really fueled something of a misunderstanding of the kinds of answers that science can give us. And that's meant that we've got a lot more assumptions creeping into the decision-making process in a forensic reconstruction. So if we've got gunshot residue, you fired a gun. And it's this that's leading to these cases of misinterpreted evidence. So we need really good science, good physical science, and we need really good behavioural science because we've got physical evidence and we've got human decision makers. So that's exactly what we're trying to do in the research that we're doing at UCL. We want to do the studies that will produce the data that will enable us to understand what the evidence means in specific contexts. And we're doing that in two ways. There are 2 parts of the equation. The first is looking at the physical evidence, so understanding how and when it moves, and we're calling that trace evidence dynamics. The second area is looking at the human factors in the forensic reconstruction process. So trying to understand much, much better how decisions are being made at the crime scene, in the lab, and in court, and how those factors that are influencing those decisions are affecting what we understand the evidence to mean. So the first area, trace evidence dynamics. We've said that we are great at being able to detect materials and we're great at being able to tell people what they're made of. But if we want to know what it means, we've got to know how and when do they transfer. So we're doing a whole range of different studies. We're looking at different types of trace material, and one of them that we've looked at is gunshot residue. So in this study, we got a volunteer to fire a gun. I do have quite a cool job. We got this volunteer to fire a gun. They then shook hands with a colleague, and then the colleague got on with their day-to-day activities. And what we observed was that the colleague, so the one who hadn't fired a gun, had gunshot residue on them. And more than that, they were able to transfer that residue onto other people and onto other objects. So what does that mean? Did anybody get the train down to Folkestone? Quite a few, right. A few of you could very well test positive for gunshot residue now. It would be because you do have gunshot residue on you, and I'm guessing it's probably not because you fired a gun this morning. It could be that as you were at the station, the train pulled in, you picked that particular train carriage, you opened the door, you got in, you maybe touched a grab rail, you touched a seat, you touched something in the overhead compartment, and you managed to pick up some gunshot residue that was already there. That is an incredibly important distinction. We're also looking at other forms of evidence. As I said, we're looking at trace DNA, that's another one. And given what we now, all of us know about quite how many skin cells we've been shedding in the last 10 minutes, it won't surprise you if I tell you that if somebody uses a knife, we can detect their DNA on that knife. But what we're also beginning to see in the studies that we're doing is that it is possible for that person who's using a knife to transfer your DNA onto that knife. So that's a knife with your DNA on it, but you have never touched it. That is important to know, especially if you're in the dock and you're innocent. So the second area that we're looking at, the human factors in this process. We're aware that there's lots in the literature that talks about just how sensitive human decision makers are to external influences. But a really critical question that we wanted to ask was, does the context that the scientist is exposed to at the beginning of a process, so at the crime scene, influence the decisions that they make later down the line? And does that change what they understand the evidence to mean? So to answer that, we did a study. We set up a mock crime, and we had a series of graves, and we had very clearly male skeletons, and they were buried in clothing along with some other artifacts that you often find in graves, so mobile phones, train tickets, contact lenses, coins, that kind of thing. I said I had quite a cool job. And we got our participants to come in, and we got them to excavate a grave, recover the remains, and bring them back to the lab. So our first group of participants were asked to excavate graves where we had this male skeleton that had been dressed in female clothing. Our second group of participants excavated a grave where the male skeleton had been dressed in neutral clothing. So they each excavated their graves, brought the remains back to the lab. Once they were back at the lab, we got them to lay out the skeleton, and we asked them then to do a very standard sex assessment of the skeleton. So is it a male or is it a female? And what we discovered was quite interesting. So in that first group, so these are the guys who had excavated the grave, the male skeleton was wearing female clothing. And in that group, one person said, these skeletal remains are male. Two people said, they're possibly male. 5 people said, we can't determine. They're male or female, but we can't say which. And 3 people said, this skeleton is possibly female. So that was the first group with the female clothing. The second group, we started seeing some differences, and this is when it got quite interesting. In that group, 7 people said that the male skeleton was male. 2 people said possibly male. 1 person said it was undetermined, and nobody said possibly female. So already between those 2 groups, we could see a significant difference in terms of how the context had influenced the decision. We also had a third group. Now these people came just to the lab and they just saw the skeleton in the lab, and we asked them to do the same process, the same sex assessment. And in that group, every single person said that the male remains were male. So what that experiment was showing us is that context at the beginning of a process really is seeming to have some kind of influence on the decisions that are made later down the line. And we're calling this cascade bias, where something that is inputted at the beginning has a manifestation at later stages, and it's affecting what we understand the evidence to mean. It is so important that we know this happens, and it's really important that we know when it happens, if we're going to be able to give very clear, transparent understanding of what the evidence means to a court. So it is possible that at the moment, we're not always going to be able to interpret what the forensic evidence means, because either we don't have the data that we need sufficiently to know how and when that trace material has transferred, or we don't fully understand and fully know all the factors that are influencing a decision. So these kinds of experiments that can produce this kind of data are just gold dust. They are so helpful and they are helping us find the patterns. They're also really important because they can have a real impact in the world. So just to underline how important, I just want to take you back to that case that I mentioned at the beginning. So the case where we had these trace metallic particles on the victim and in the suspect's vehicle, and it was the critical evidence. In that case, there were two assumptions made about those trace particles. The first was how and when did they transfer onto the victim. But the second one was about how rare are they. And it's these two assumptions that really show very neatly the two aspects that we've got to the problem of understanding and interpreting what the evidence means. So these are the particles. There we go. And you can see that they are very, very rounded. They're microscopic. So the scale at the top is 50 microns. So a hair on your head is about 60 microns. So we can get about 2 or 3 of these particles within one hair's width. So they're tiny. They are made of rare earth elements, and they are very, very smooth and round. And they're produced when you use a disposable cigarette lighter. So you know when you flick the wheel and produce a flame? That's when these particles are produced. When the scientists identified these in the samples in the case, they had never come across them before, never seen them. And so it was assumed that these particles were incredibly rare. They also looked at their shape and their size and made an assumption that if they were transferred onto clothing, they would fall off very quickly, a matter of a few minutes. And in that case, we had 13 of those particles on the victim and 5 in the vehicle. So because we had a very small number of incredibly rare particles that were going to fall off clothing very quickly, it was assumed that the victim must have been in the vehicle very shortly before death. So we wanted to test those two assumptions. So the first one we wanted to test was how rare are these particles? So essentially the question was, how many particles do you get when you flick a disposable lighter? So we got a whole range of different brands of cigarette lighter, and we basically did a lot and lot of repeats to find out how many particles you could get. I got the most extraordinarily painful blisters on my thumbs doing this, but what I can tell you through that is that you don't get a few particles when you flick a lighter. You get on average 4,000 particles. These are not rare. The second experiment we did was trying to find out would they fall off clothing quickly if they were transferred. And so we transferred the particles onto clothing, and then we observed the clothing over a period of time to see how many particles were left. And we observed after a few seconds, after a few minutes, after multiple minutes, after a few hours. After 18 hours, those particles were still on that clothing. So we were able to show that they don't fall off that quickly. You've still got particles remaining many hours after they've been transferred. So what those experiments were able to show us is that the original evidence in that trial was not nearly as strong as had been originally thought. Those particles were not rare. You're getting thousands of them, not a few. And they don't fall off quickly. It's not that they're falling off in a few minutes. They are still there many hours later. And that meant that there were lots and lots of other opportunities, lots of other places and times when those particles could have transferred onto the victim. That meant that the significance of those metallic particles in that case was completely changed. So 7 years after that conviction, after being in prison, those sentences were quashed. And that is why these kinds of experiments are so important. We need this kind of work that can produce the data, that can test assumptions, and actually provide us with that evidence base so that we can understand what the evidence means. So forensic science isn't always that open and shut case that we might think it is, or that we might be led to believe that it is. It is possible that we could find your DNA on clothing at a crime scene that you have never worn. It is possible that you could test positive for explosive residue as you go through the airport scanner, having got a taxi to the airport. It's possible that because of extraneous information, such as clothing on a skeleton or coming across something you've never observed before, that can influence what we understand the evidence to mean. But at the moment, we just don't have the data that we need to be able to always understand and know when that is happening. And that means that forensic science evidence isn't always going to be interpreted accurately. So we need a change. We need a change that moves our focus from being primarily on developing the technology that will get us an understanding of what a substance is and what it's made of and who it belongs to. And we need to get very serious about getting the answers that we need to those questions of how and when do those materials transfer. And we also need to really increase our understanding of all the variable factors that are influencing the decision-making at the crime scene, in the lab, and in court. To do that, we're going to need a lot more people asking these kinds of questions, and we need them to then do the experiments that are going to produce the kind of data that will help us get the answers that we need. But for that to happen, we need an even bigger change. We need to completely change the environment. We need to create an environment where this kind of research is valued and where this kind of research is enabled to happen. And it's a big ask, but if we can do it, we have got such an incredible opportunity to reduce the chances of forensic science evidence being misinterpreted. And we need to do that so that you never have to be that innocent person in the dock. Thank you.